Hey, it's Alex Williams with the News Stack here at KubeCon in Barcelona, and today I am speaking with Maya Kaczorowski, Product Manager at Google. Hi.
Hi.
Good to see you, Maya. So I wanted to just ask a few questions about container security overall and how Google views, its own posture about container security. Perhaps we could just start with that. What is the Google view about container security?
Yeah, we're sort of looking at container security in three main areas. The first one is what we're calling infrastructure security, which is how you make sure that your container development environment is secure. So typically this is configurations in Kubernetes, things like network policies, things like your IAM, user identity management, secret management, that kind of stuff. The second category is what we're calling software supply chain, which is making sure that your containers are built and deployed securely. So knowing where your images are coming from, scanning them for vulnerabilities, checking that they meet your requirements before you deploy them into your environment. And the last one is what we're calling container runtime security. So making sure that your containers are secure to run. So once you're up and running, is anybody attacking your containers? Can you detect if that's happening? How do you do forensics, et cetera, on your containers?
So what do you do? How do you support then, in that respect across those three themes?
Yeah, GKE does a lot of the kind of heavy lifting in the first category, having secure defaults and having a lot of features that you can enable, like application layer secrets management, using network policies, et cetera. But then we also have other products or work with partners in some of the other categories.
Okay. So is that a shared security model, the shared responsibility model?
Yeah, the shared responsibility model for GKE or for Kubernetes in general is a bit hard, I think, for people to understand because it's not exactly IaaS and it's not exactly PaaS either. It's sort of in this middle land. So if you think about how GKE is secured, Google is responsible for the control plane and responsible for upgrading your nodes and responsible for the actual Kubernetes binaries themselves, but you're responsible still for the worker nodes that you have and then applying those upgrades. I think a lot of other cloud providers have similar models as well here. So figuring out, making sure that's well documented, well understood by the user to see what they're responsible for.
What becomes the challenges with containerized workloads? Is the shared model still relevant as when you're not using containers?
It's just a different model, so you just have to adapt to that and make sure you're handling those pieces. People who are using containers and are new to it are often coming from virtual machines. So it's actually a lot less for them to have to control and have to secure than before. Mm-hmm. So it's a better deal in some sense for their ops team.
What has become a challenge? Because if you start scaling out containers, you're used to patching lots of, doing a lot of patching to kind of fix holes and stuff. Containers, it presents another set of challenges, doesn't it? And what might those be?
I think containers actually can help simplify your patching story. So whereas before you say you want to apply a patch or a change to your environment, you would have SSH'd into a VM, made the change manually. You might not have a record of who made that change or how that change was made. With containers, you're not changing single lines of code or single configs or things like that in a running container. You're actually changing the image and rebuilding and redeploying the whole image. And that also applies for your application code having vulnerabilities, and it applies for some open source dependency you rely on having a vulnerability, et cetera. So it actually makes it a little bit easier to manage patches because you can patch everything in your container image before you deploy it, and then manage the rollout of a patch like you would manage the rollout of any other change to your infrastructure. So you have the same monitoring, testing, canarying, et cetera, that you would expect for any other infrastructure change.
So when you're thinking about containers and the security lifecycle for containers from build to ship, how do you organize it? How do you think about that?
Yeah, so a couple of typical steps would be you check your code in somewhere. Internally at Google, that's centralized. A lot of people have a fairly decentralized code source repository. Then you would build a container image. You have to decide what your base image is going to be, and then pull in the binaries and libraries you need on top of that in your build process to actually build an application image. Then you might check that the application image meets certain requirements, such as scanning it for vulnerabilities. Mm-hmm. And then you might check that it meets certain requirements, like at deployment time, before you actually deploy it, using an admission controller. So, the one we have on GCP is called binary authorization. And then you put it into your environment, such as running it on GKE, running it on Cloud Run, running it on-prem, running it wherever you want.
So when you think about the scanning, in terms of container scanning, such as what Twistlock provides,
Yeah.
how do you see that sector of the market? What is your view? How do you guys view that in the terms of container scanning? What are you starting to see in that space evolve?
Yeah, container scanning, container vulnerability scanning is particularly interesting because if you can prevent the thing from ending up in your environment in the first place, that's better than you having to secure it after the fact, right? So as much as you can shift those security decisions to the left and make the developer have to fix it before it ends up in your environment, it's better for you from a security point of view. So there's definitely a lot of interest in scanning, including tools like Twistlock. I think what we see is, there's native scanning capabilities in the cloud, but having the next level of some of those capabilities, like looking for things like containers running as root, looking for things like secrets embedded in code, et cetera, are some of the capabilities that partners can provide really, really well.
Yeah. So how have you seen that space evolve? Like, what are some of the evolutions you've seen, and what do you see as that continuum?
I think a couple years ago, people were starting with, just really basic image scanning. Now people are looking at images in packages or packages only, looking at some of the configurations of the images. And then obviously the other area that we're seeing expansions happen is like the set of images that you're scanning for. So a lot of these scanners, could probably just do one or two OSs before, and now are covering the whole stack of Debian, Ubuntu, Alpine, CentOS, RHEL, like whatever you possibly want to scan for, Windows, for scan for vulnerabilities.
So when you're thinking about like the security stack and how it looks like for Kubernetes and GKE, how is that changing? How is that evolving? You're talking about, for instance, the shared responsibilities that come with containers and such, but how is it changing Kubernetes and GKE?
I think the model isn't changing per se. Maybe what people are worrying about is changing a lot more. So people are becoming less and less worried about the pieces that they don't have to manage, or pieces that they used to have to manage but that are now simpler for whatever reason. So some of these secure defaults more secure defaults being built into Kubernetes or built into GKE, taking that responsibility away from the user having to worry about it. One of the things that I think is really powerful and that GKE does around auto upgrades means that, yes, the user is still responsible for applying the upgrade, but even that, they can enable a feature that lets them be no longer responsible and no longer have to worry about that. Giving them, they still have the ability to do it if they want to, but they don't have to. And that's a huge security benefit.
So when you're thinking about, the overall software supply chain, which it's so interdependent now, and then we saw, like, for instance, what happened to Docker when they announced that they had that the hack and 190,000 accounts were compromised. How did you guys react to that? What was your initial reaction to that?
Went and checked where we were using, Docker Hub anywhere that had to be replaced.
Yeah.
And I'm sure that's everybody else's reaction
right.
too. Yeah.
But I'm curious about that approach that you took.
Yeah. The concern with all of these types of supply chain attacks, like NPM that happened, there was also the Docker Hub vuln last year, not vuln, I should say, the embedded images that had cryptocurrency malware last year. All of these are just kind of re-emphasizing the same concern, which is you can't trust things that you didn't do yourself, right? Or you can't trust things that don't come from some trusted set of parties that you trust for whatever reason. And so for us, and I'm sure for a lot of our customers, it was how do we go verify that we're not using this? And if we are, we can go revoke it or redeploy it or patch it or whatever it happens to be. So the first step is figuring out what's actually in your environment, which I say that kind of like jokingly because it's actually quite hard to figure out what you're running, even with containers. You can look at the images in your repository, but you don't necessarily know that it's currently running. And so step one, look at the images that you have in your repository. Step two, figure out if it's currently running to try to figure out what you should patch first or what you should redeploy first. Then actually do that. And that's usually the sequence of steps I see people take. Now, I say this, like jokingly, like, oh, this is kind of hard. And, it's still way easier than it ever was with virtual machines, right? Where you really had no idea what was running and you didn't have a central inventory unless it was like a spreadsheet that somebody was keeping up to date. So it's still, a couple steps for you to figure out if you're affected and take action, but way better than it was a few years ago.
So review those steps again. What are you affected?
You will go look at your repository. See if you have any images that are affected in your repository. So you can use a scanner like we talked about earlier. If it's a particular vulnerability, you can scan to see if that vulnerability exists in your images in your repository. Now, say you have like 10,000 images in your repository, but you only have 3,000 in production, right? You don't actually know if that particular image that you found is running. So the next step is, and this is the part that's kind of hard, you can look at your logs to figure out if it was deployed. You might actually try to look at existing running containers and figure out if something is up and running that has that particular vuln, and kind of do that reconciliation of what's in your environment. And then I would patch the images that are known to be vulnerable. And the reason I say that, the reason we even do that step of figuring out if it's in your infrastructure is that it might be too much for you to reasonably patch, in a couple of hours or a day or whatever your timeline is. And so narrowing it down to the things that are currently in production saves you a lot of time. So patch those, rebuild the image, and then redeploy it. And use a Bluegreen deployment to make sure you don't have any downtime in your environment while you're actually moving that workload over to the new patched image.
Is Bluegreen deployment becoming more understood? I mean,
I hope so. For people who haven't heard of it before, a Bluegreen deployment is you have a blue workload running, and you have a new green workload that you want to deploy in this place of the blue workload. And what you do is you spin up, the same amount of workload, the same amount of capacity, and then you slowly load balance the traffic over from the blue workload to the green workload. The idea here being you can roll back at any time, right? If you see that something's not working, once you have the green workload running at 100%, you can kill the blue workload. This, to me, is one of the big benefits of using microservices and using containers, that you can actually do this kind of rollout. SREs obviously love it. And what I love from a security point of view is it means I can patch things live, right? I don't have to take the workload down to be able to patch it, which is what, again, I had to historically do with VMs. I used to have to take, Sunday 2 a.m. maintenance window. You can't log into your banking application because they're busy patching.
Right.
And that doesn't have to happen anymore with something like a Bluegreen deployment. Now, to kind of what you were asking, are people using it more and more? It's really hard to say. A lot of it is still very kind of self-built tooling in that regard.
Yeah.
There isn't anything great in that space right now.
That's a space then that will necessarily have to evolve if container architectures do become more predominant, as they are, as we can tell.
Yeah, definitely. The deployment tools like Spinnaker, like whatever you're using, are going to have to take that into account.
Yeah, I imagine that's going to have to be a consideration for the Continuous Delivery Foundation.
I would hope so.
Well, we'll see. But when you're thinking about that in terms of this recent the Docker Hub attack, was there any learnings that you came out of that? Was there anything like insightful for you that came out of that experience? It's an ongoing process too. I mean, you do learn over time about the effects of it. But was there anything in that you found that is I think worthy of just exploring more?
Not necessarily. I mean, obviously you're not going to put any blame on anyone. Like, it was everyone gets attacked. It's not
Yeah, everyone gets attacked.
It's unfortunate that it happened. I think the takeaway for me is it's unfortunate that so much of the trust of the containers that we have relies in one place right now.
Right.
And to me, that was a big kind of red flag of, maybe this should be more distributed.
Right. What should be more distributed then?
The images that people trust.
The images that people trust.
Yeah.
So what would be an effective way to do that?
It would be great if there was, I don't know, I'm just talking out loud. I don't know, it would be great if there was like a massive open source repository of all the images that people wanted, where I could choose what to trust based on individual signatures rather than based on the fact that they're from Docker Hub. Like, it'd be great if I could trust specifically Debian and only Debian, and specifically Google and only Google, but not trust, arbitrary other signatures.
So what is the difference then right now? Is it that with Docker Hub, then you're just using an image that could be uploaded by...
It could be uploaded by anyone. It could be
Right.
uploaded by an attacker, which is what the cryptocurrency mining images were last
Right.
year. You don't know if it's an official... I mean, there are a set of official images, but you don't know all the other images, who they belong to really, if they're scanned for vulnerabilities. When they were last updated, but that's like not a lot of useful information. Like, you don't know if they're maintained on an ongoing basis. It's almost like saying, like, this is a set of common images that you need that everyone's gonna use, and somebody's committed to maintaining it, right? Kind of like you see with some of the CNCF projects, right? There's a set of maintainers, and people respond to PRs and respond to security vulnerabilities and that kind of stuff. Like we need some accountability around the images that are there.
Some accountability around the image that you're there, and you think that could be done through an open source project, for example,
Possibly,
with maintainers,
yeah.
right?
I mean, it would need a lot of work for everybody who's currently maintaining those images to say that we're going to do it, and they would need to do something like sign the images, which they're not currently necessarily
Right.
doing. We need a way of enforcing those signatures, which is not necessarily possible. Like it's not one piece
It's
of
not,
infrastructure.
right.
Yeah.
In terms of, for example, how would that, for instance, mitigate the token authentication issue? I think, as far as I understand, I'm very much of a neophyte when it comes to security, but with developer tools in particular. But when you're thinking about what happened with Docker, then the biggest concern, as I understand, were those tokens, right? So essentially, if those tokens get compromised, then but essentially it's like, if one person has keys to 100 bank accounts, for example, and that person gets hacked, then that makes those 100 individual accounts just more vulnerable.
Yeah. So this meant that they could. So the token meant that somebody could push another change to the repository. Based on the fact that they were using that token, right? So they could have made an arbitrarily bad push, like purposefully put in malware or something like that if they had access to that. I'm a little bit less worried about that, although it is concerning because it's fairly localized. It's localized to whoever had their accounts compromised. It's localized to that. I'm more worried about some upstream dependency that all of these projects have, or all of these images have, where again, a developer is compromised or a set of tokens is or something like that will then affect a ton of the infrastructure. So like the NPM issue that happened last September to me is much scarier than what happened to Docker Hub recently because, okay, it was a critical package that's involved in so many different projects that people use, and they effectively could do whatever they wanted with it.
Right.
Right? That's really terrifying.
Yeah. Yeah. So, going forward then, do you see any open source projects on the horizon that are starting to kind of think about this as kind of from that context that you are describing?
I don't think anything is doing everything that we've talked about. The open source projects around the supply chain are trying to solve some of those issues. So Critis is one from Google that looks at the metadata of your images and helps you enforce that certain metadata requirements are met before you deploy images to your infrastructure. In Toto is one about your supply chain as well, lets you kind of define arbitrary requirements for how your supply chain should look and then enforce that's met. And then I think the areas that I'm also excited about are some of they're not open source project, but open source tools around minimizing the risk of this happening. So if you're building your own images, your own container images, using something like a distroless base, which is from Google, lets you have the minimum that you need for an image to run without having like a package manager or a shell or a bunch of things that an attacker would typically exploit, and not having a lot of the bloat where some of these vulnerabilities come up, right? Helping you minimize what you eventually need to patch if it's actually compromised.
So minimizing what exactly then?
Minimizing what's in your container image.
Right.
So your container image shouldn't have anything that it doesn't need for your container to run. So a shell or a package manager.
Right.
If you can get away with not having those, then take them out because that just like introduces additional surface
Because you're
attack.
just trusting the package really that you're putting into the container at that point, and you don't necessarily know what's in the package.
So it's a couple things. It's literally like having something like a package manager means that it's easier for an attacker to use whatever they want inside the container. Some of their attacks rely on the fact that there's a package manager there. So if you don't have a package manager, hey, that's a little bit easier. The second one is just having less stuff. If you have fewer things in the environment, there are fewer things to patch, period, right? Vulnerabilities will occur everywhere. If you can have 20% less things, it's 20% less vulnerabilities for you have to manage, right? So that makes your life a little bit easier.
Right, just is like just doing the basics.
Yeah.
Right, making sure your house is locked when you leave, right?
Yeah.
Things like that, which was so simple. But so I'm curious then about zero trust, and that's a concept we're hearing more about.
Now, what do you mean when you say zero trust?
Well, when I'm thinking of zero trust, like I was just listening to the GitLab presentation earlier, and I thought they said it was summed up well, and like just providing that context. If you look at where the space now is evolving for developers moving into more, container-based environments. You need to know and understand, what are the pathways that, that attackers can use, when you have a large, for instance, hundreds of developers or thousands of developers, who, are using the same platform. So for instance, like, I was actually, I wish I had my images in front of me, but there was one example, for instance, of like, plugins. You got to be careful about keeping your plugins updated because it can lead to remote, executional attacks, right?
Mm-hmm.
So for me, it means more like, kind of like I think what you're saying already is like, focusing on understanding what cloud native architectures provide, right? And understanding what those new attack services, might be, and then looking for paths to kind of mitigate, those problems as much as possible.
Yeah, so that's very similar to what I think of as zero trust. I've heard two different kind of perspectives on zero trust, which is why I was wondering which one you were coming from. One is that I don't trust my users anymore, and how to control access to from users to applications. That's kind of the Beyond Corp model. That's been a discussion for many years now. The second concept around zero trust is around this cloud native security concept, which is I now have everything in containers and in microservices, and they need to talk to each other. They shouldn't inherently trust each other, right? If every service talks to every other service, then I should be able to control how those things are accessing each other, what data they have access to, et cetera. Just because there's a service running in my infrastructure and it's inside my firewall, again, this is parallel to how we thought about users, several years ago, doesn't mean that it's trusted. And so what you're describing is like, I deployed an application and could be malicious, right? Just the fact that I deployed it shouldn't necessarily be sufficient to give it access to other things in my infrastructure.
Mm-hmm. One way it was described is like GitLab has a zero trust roadmap, and the number one priority for them is GitLab.com, right? And for making sure that they're following the basic security principles to make sure that's protected.
Got it.
And then they looked at and the second one is endpoints, and then the third would be the back-end infrastructure.
Okay. This is definitely a different way of talking about zero trust than I've heard before.
Oh, really?
Good to hear it.
Yeah. They're also he was also.
And so this is mostly around supply chain security. It sounds like.
Yeah.
Okay.
I mean, and GitLab I think is an interesting example because they're a company that has actually grown quite a bit. I think they had a few hundred employees last year, and now they're up to 600, and they're looking to double that number of employees over the next year or so. And so their concern is like if everyone's going to be using, you can have so many new people, like it could be in an airport, and you don't know who's around you, who's who's kind of like trying to figure out what you're doing, right? So their philosophy was that, but their first center is GitLab.com, so that's their biggest priority.
Yeah.
But then second would be those endpoints because employees are everywhere, and then the third was then the tools. I just thought it was an interesting kind of approach.
Yeah, definitely.
Is there a Google approach to this? Is there like a zero trust model that you're advocating?
I think there's so many. Depends what you're looking at. Like infrastructure security or application security or what. If you're looking at application security, then what we shared around like Beyond Corp a few years ago is certainly the way that we're thinking about end users accessing applications. So to parallel to what you just described, it'd be like accessing the internal websites or et cetera. How do you verify that those users are trusted? Just being on a particular network is no longer sufficient. Like being on a VPN or being having a certain set of credentials is no longer sufficient. You need to have a bunch of different context-aware, risk-based assessments to determine is this person actually able to access that particular piece of data.
Mm-hmm.
And then for internal systems, it's kind of more around what we think around service-to-service communication. So the parallel that we talk about externally is Istio, like making sure that the two services that are talking to each other are actually authorized to talk to each other. The communications are authenticated, so I actually know it's that service. It's encrypted, so it's protected in transit. And then you can actually make some decisions based on
that. I was going to ask then about some of these new attack services that are starting to appear. I wanted to just be clarified that what they were talking about was vulnerable plugin allows remote code execution, and they were saying that a prevention is dependency scanning, for example.
Yeah.
lateral move to another pod, which, can be a real problem, means you should, to prevent that, you should have egress policy to whitelist pod interaction, not default settings. Other pod could talk to API server, so that means that you should need to really have role-based access control with minimal permission, right? So it just seems like these are just, things that, it happens to all of us, right? It's like, I may be a journalist, I may have been, writing stories for most of my career, but I can always learn something new to make, to learn how to write a story better, right? Is that a philosophy that goes with Zero? Is it kind of the thing that applies here? When you're talking about new attack surfaces, and is it just constantly being reminding yourself that, oh, there are these preventions that I could do that are just kind of common sense?
I don't know. So there are certainly new attack surfaces. I don't know that the protections are significantly different, and like the concepts aren't different. How you actually implement them might be different. Like something like network policy, right, is a very Kubernetes specific concept, or RBAC is versus RBAC is not in Kubernetes, but like the implementation is specific to Kubernetes. The concept is more general.
Right.
So you can apply that to many different things. I think where people struggle is figuring out what the next thing to implement is, or if the next thing is the right thing to implement, because it's a laundry list. Like no matter what you're looking at, you get kind of 30 items to go work on, or 200 items to go work on, or whatever. And how do you figure out that I actually want to do, RBAC first and network policy second, and why? And the problem there is that there isn't a one answer for every single environment. It really depends on the risks that a particular organization is dealing with to determine whether or not they should pursue a particular control.
And one last question I'd like to ask. The security space has been known for a long time by big security providers, and there is definitely a sense of dread that everyone has about being attacked. It's always this existential fear, right, that you could be attacked potentially, especially when there's a bad attack that happens. But a lot of the tools have traditionally been like proprietary tools. They've been developed by security vendors, for example. How do you see the open source security space evolving right now? Is there more interest in it, and if so, how would you quantify that?
Yeah, the open source security space, unlike infrastructure per se, isn't evolving as quickly, I think, right? There's obviously some around containers, a lot of tools, including security tools, but there isn't a lot in the general security space. Where you see some open source security work being more popular is around helping to do kind of introspection of what's currently going on in your environment, whether that's something like what are the existing configs that you have applied, like going and figuring that out for you. What systems are talking to each other, figuring that out for you. It's not so much the enforcement of that, but it's the initial mapping of your environment. Because especially as you let kind of developers go do what they want to do, you suddenly have no idea what your environment looks like anymore, right? And so a lot of security tools, the open source security tools, are sort of in that space today. I hope they're going to evolve and have more general tools. The other area that I kind of want to mention here is that there are a lot of open source projects that are starting to have really strong security teams. So if I look at something like Kubernetes, there's a product security team that responds to incidents in Kubernetes, right? And that's something, as a concept, that was probably fairly foreign, a couple years ago, except for Linux and some of these really, really giant projects. The idea that there's somebody who will answer your email if you think that you found a security vulnerability and actually try to fix it, and do so kind of in embargo, in a coordinated fashion, was a completely foreign concept a couple of years ago.
Right. Well, Maya, thank you so much for taking the time to talk today. I really appreciate it.
Thank you so much for having me.